So this is question 11. It says write down the spatial name of a polygon with 5 sides. So you should know this. The polygon with 5 sides, it's called a pentagon. Most people would know this. If you want to remember it, you can associate it with the building, the Pentagon building, and US. In the US, it's got like 5 sections. So pentagon is the shape with 5 sides. Heptagon, it's got 7. So pentagon and heptagon, I think some people they confuse those. So just be clear, pentagon, 5 sides. Okay, so state for a regular 5-sided shape. My editor here, I don't know what he was doing. So this one was supposed to read 5-sided shape. Express the number of lines of symmetry. So when they say regular, what they mean is that the sides, they're equal. For any regular shape, a regular polygon, the number of lines of symmetry equals the number of sides. So the number of lines of symmetry for this one equal to 5 for a pentagon, okay? And then the order of rotational symmetry, it's also order 5. So you just remember this because these are like dead giveaways. They test this question the very same way. They just tell you it's a regular, maybe hexagon or something. Then they ask you the order of rotational symmetry. It's equal to the number of sides. Okay, so let's move to question 12 real quickly. So question 12, what does it say? So question 12 says, it asks us to solve this inequality. And this inequality, it's got 2 sections. The first section is this part here. So you can read it and it makes sense up to this part. And you can also read it and make sense for this part here going to the right. So what you do is, whenever you want to solve such inequality, by the way, this is a popular question. If you don't get any question on this in paper 1, it's most probably that in paper 2 you get something. So let's quickly run through it. So you first solve one side of the equation. So one side of the inequality, sorry. So this is 2x minus 1. This in the middle here, it's 2x minus 1. It's not just 2x. Okay, so it's 2x minus 1, this section. So always split it into 3. Make sure that there are 3 distinct ones there. So once you're done with this, what you do is shift the variables such that you get positives. Okay, so I would shift this as opposed to shifting this, because if I shift this, then I create a negative, of which it's okay to create negative, but then sometimes if you divide by negatives and then you don't change the inequality sign, then you get it wrong. So the way that I advise people is to just head on start by avoiding negative signs. So here I divided both sides by 3, and then I got, let me actually write it the way that it's written there. So I got x, this one would be 1. Okay, this is the first part, and you also have to do for the second part as well. The second part would be, let me rub this. So the second part would be this part here. Remember, this whole thing, it's a single value. Okay, so yeah, so again 2x plus this one goes there, so this one becomes plus 1. Okay, so why did I do this? This inequality is strict. Okay, so this is 12, this is 2x, then you divide both sides by 2, then you get x less than 6. Okay, so now you're supposed to combine. What you do, because you're told that you should express it in this form, so what you do is write your x here, then you start writing your inequality. So this one is facing away from x, so this one will be 6. Therefore, for the larger number, so for the smaller number, obviously it'd be here, and this one is facing towards x. Okay, so I get this, and this would be your answer, and then you're done with the inequality. Let's quickly move to question 13. So question 13, in the diagram, A, B, and C are positions of they are positions of balls, basically, where BA, which is this, so BA, it's equal to BC. Okay, so BA is equal to BC like this. So these ones are equal. So the ball at C is as a bearing, thus, okay, from ball at B. Calculate ACB. So ACB would be this. This is what we are required to calculate, okay? So there are two ways that you can go about it. This and this, they're equal to this exterior angle here. So opposite interior angles of a triangle, they're equal to the exterior angle. Okay, that's one way to look at it. So you can actually just say, okay, let's say this is theta. So you'd have theta plus theta. You'd have 2 theta equal to 116 degrees. Okay, so theta would be equal to 116 degrees divided by 2. So you get 58, I think. So this one would be 58 degrees. Or another way that you can compute the same would be to find this angle here. So this angle here you get from 180 minus 116. So you can say 180 minus 120, you get 180 minus 120, you get 60. So let me show you an interesting way to do it. So minus 116. So you say 180 minus 120 since that's simpler. But then you have to maintain 116. So you say plus 4. So here you actually get 60 plus 4. So you get what? 64. Look at that. So this one would be 64 degrees. And if this one is 64, this one's they're equal. You have to say 180 minus 64. Jesus. And then again you get 116. Then you divide this by 2, and then you get 58. Okay. So this useful theorem, just use it, because it will save you some steps, and you'll be able to compute the answer very fast. Remember, this is one answer, one mark, so they only need your answer, only that, nothing else. So here we found out that that's 58. So this one is 58. This one is 58. Okay, and then you're asked to find the bearing of the ball A from the ball at C. So the ball at C, wherever it says from, that's where you're supposed to draw your cardinal north. So in our case, it's from the ball C, so we're supposed to draw it C. And then it should lead to A. So they're looking for which angle? They're looking for this angle here, this bearing, okay? So how do you find this bearing? Here you can find this angle here. This angle and this angle, they are Z angles. So this one would be 64, okay? So afterwards, the bearing would be equal to 360 minus 58 minus 64. Okay, so here you would have 302. This one gives you 302 minus 64. Okay, then here you can say 302 minus 60, then minus 4. So 302 minus 60, you get 240. 242. Okay, so 242 minus 4, you get what? 238 degrees, just like this, and then you're done. Okay, so you can work out any way that's convenient for you, but then I was just doing this just because it's paper 1, so you're not allowed to use a calculator. Let's quickly move to question 14. So we're given this log. This is also a popular question, so take note of it like very carefully. So we have this, we're given this value for this log, and then evaluate this. What they are trying to have you do is to try to manipulate this such that it's similar to this, so that you can substitute this. Okay, so for example, log this 10 0.07 like this, it would be equal to log this 10. Wherever you see a decimal in this type of questions, just change it to a fraction. It's usually revealing that way. And so you have log plus 10, 7 minus log plus 10, 100, like this. Okay, so log plus 10, 7 at 0.7 8451 is your given. Then log base 10 100 is equal to 2. Whenever you're in base 10, whatever number of zeros you have after this one, that's equal to your value. So here we're just supposed to get this minus this. So this one is bigger, so it's supposed to be minus. Then we can say 2 minus that. So it'd be, let me work it out real quickly. So 0, 0, 0 minus, this is 8451 with this, and then you get 0 here. Then here, you get 9, here 6, then here 4, then here 5, then here 5, then here 9, then here 1, then here 1, then here 1. So you get negative 1.1549. Just double check, okay? But then you're supposed to get something like this. So you just have to manipulate whatever you're given such that you can use whatever you have. So in the second part, we have log base 10 49. So notice the association that 49 has with 7 is that 49 equals to 7 squared, just like this. And then according to one law of logarithms, whenever we have anything to the power for a logarithm, we can kick this such that it goes there, and then we're left with this. This one we already know. So this one is 0.8451, like this. So multiply by 2. Just multiply this by 2, you get 902 here. So 902. And then you just multiply this by 2, you get 16, which is this. And then you're done. Okay. So this is what you get for the A part and the B part. You can pause it if you're not sure, because I need to erase this so that we can create some space. Let's quickly move to B part. On the B part, we have log base 2 1 over 64. This one, it involves numbers only, but then I notice that this is B part, so it's disconnected from this. You're not expected to use this, okay? This is now a different situation. So there are many ways to work it out. I'll show you a very quick one. So here it can be log base 2. This would be 1 over 2 to the power is it 8. So 2 by 2, get 4 by 2. You get 8 by 2, you get 16 by 2, get 32 by 2, get 64. So 1, 2, 3, 4, 5, 6. So it's 2 to the power 6 here. So I'd say 8. So this would be log base 2, 2 to the power negative 6, according to laws of indices. Okay, so this would be negative 6 log 2. This is equal to 1. Whenever you have a logarithm where this number it's equal to the base, it's always equal to 1. So you get negative 6 here. This is one way to work it out. But then if you want another way, which is very common, you say let log base 2 1 by 64 equal to x. And then this base here kicks this number to the power, to be the power, and then you get 64 here. So you get 2 to the power x equal to 1 over 2 to the power 6. Here we established that this is 2 to the power 6. So here 2 to the power negative 6. Here x is equal to negative 6. And the clutch here is that these bases, they should be equal for you to say these indices, they are equal. And then you're done. This is also equally faster. The other one I just thought, like, it's not very common, but I love that method. So yeah, let's quickly move to question 15. Question 15, okay. The table shows part of Mr. Dube's payslip for a particular month. So we're given this payslip. These are earnings. So this is the money that's coming to him. These are deductions. These are the money that are being deducted. So there are certain fees there are certain things that Mr. Dube has to pay for before he even get his net salary. So that's it. Deductions also means subtraction. So to deduct something is to subtract something. So you just know that this is the money that Mr. Dube won't be getting as part of his payslip. So the total deductions would be this. Okay. So here you get $6 plus $10 is $16, $16 plus $8 is $24, $24 plus 1750. Okay, so here what do we get? We get 0, 5 here, this is 11, so on K1 here, this is 4150. Okay, so this is 4150. Don't forget the units, those are dollars. To get the net salary, we have to say the gross salary minus the deductions. Okay, so here the mistake that most students would make is they would take the basic salary here as the gross salary. This is not the way to go about it. You should also add the allowances, overtime, anything, so that you get the gross salary first. Okay, so your gross salary would be, I'm just going to work at it haphazardly here. So this is 100, this is 129. Okay, these are allowances, so they're earnings. This person is receiving all this money, $275. So when we add this, what do we get? This is 0, this is 0, this is 410. So that's we carry one set of 10 here. So we have 3 and 10. So we carry 1 again. Then here we have $504. This one is the gross salary. Okay. So gross salary is what we just calculated here. We added all those earnings, including basic salary. And now the net salary would be equal to, so net salary equals gross salary minus total deductions. So this would be $504 minus total deductions. I think what do we get the last time? I think this is 16 plus 8, you get 24. 24 plus 1750. So it would be 24 plus 1750 here. What did you get again? You got 5 here would be 11. So okay, 1 here would be 4. So it was 4150. So minus 4150 like this. And what do you get? $504 minus 4150. So you get 0 here, then here you get 5, then here you get 2, or 50 minus 4, you get what? 46. Okay, so you get 462.50. So 462.50, and then just remember to put your sign. Okay, so your sign will be $sign in this case. So yeah, just a recap. This one was tricky. You had to recognize that basic salary is not the same as gross salary. The gross salary includes all allowances, all bonuses, all overtime payments. So all those, they're included here, and you have to find the gross salary first, and then you check the deductions. So that will be it. So let's move to the B part. Yeah, and then on the B part, it says express the pension contribution as a percentage of a basic salary. Okay, so I'm going to use the space without dropping anything. So the pension contribution would be 6. So pension contribution will be $6. So you can just write 6. Okay, so it'd be 6 divided by 275. So 6 over 275 multiplied by 100%. Remember to put 100% here. It's not by 100, it's by 100%. Okay, so here you can say 25 into 27. Recognize that 25 is a factor here and so is a factor here. That's why we're using it. So you get 1, remember 2, then 25, you get 1, then here you get 4. Okay, then you get 24 over 11%, which is equal to what? Which is equal to 2 and 2 over 11%, like this. This would be your answer. And yeah, just make sure that you do it in
on in a clean way, not the way that I was doing. I just wanted to save up space without dropping stuff that we're doing.
So in the next video, we'll continue from question 16 up to 20. So cheers, remember to like, share and subscribe.